Dear students, today's topic is electronic configuration. But before starting with this topic, let's discuss what is a shell. Shell. Electrons revolve around the nucleus in fixed circular paths. Now these are the circular paths you can see over here called shells, orbits or energy levels. So we say that electrons are revolving around the nucleus in these circular paths, and these circular paths are known as shells, orbits or energy levels. Shell is represented by n, that is small n, where n equals to 1, 2, 3, 4 and so on. 1 is considered as first shell, 2 is considered as a second shell, 3 is considered as a third shell, 4 is considered as a fourth shell and so on. Now the basic shells are first shell, that is K shell, second shell which is called as L shell, third shell which is called as M shell, fourth shell which is called as N shell, fifth shell which is called as O shell. Now every shell has a specific number of electrons, and in order to know about specific number of electrons in a particular shell, let's move on to now electronic configuration. Electronic configuration. The distribution or arrangement of electrons around the nucleus in orbits or shells is called the electronic configuration. Mean to say that how electrons are distributed or arranged around the nucleus, that is called as electronic configuration. The electrons are distributed around the nucleus in various orbits or energy levels or shells. These orbits are numbered as 1, 2, 3, 4, 5, 6, 7 and so on. These orbits are represented by K, L, M and etc. We have discussed it right away. The maximum number of electrons in a particular orbit or shell is given by the formula 2n square, where n equals to 1, 2, 3, 4 and so on. So mean to say that in order to find out the number of electrons in a particular shell, we use the formula that is 2n square, and we have discussed n equals to 1, 2, 3, 4 etc., which is considered as the number of shells. Now if you have a look over here, to find maximum number of electrons in a particular shell, we use the formula 2n square, where n equals to number of shells, that is 1, 2, 3 and so on. Now let's take an example. Now number of electrons in K shell. So by using the formula 2n square, as we know that K is the first shell, so n will be equal to 1. So substituting the value over here 2, instead of n we are going to write down 1 over here. So after this we will get 2 electrons. So 2 electrons are present in K shell. So if you move on over here, a table is given to you on page number 48. If you see this table, now first shell is called as K shell, and the number of electrons can be found out by using this formula 2n square. So by substituting the value, if you see over here n is 1 over here, so we get 2. So second shell is called as L shell by using the formula 2n square, where n equals to what? 2. So it's by substituting the values over here, so we get 8. Now third shell is called as the M shell, and the number of electrons can be found out by using the formula where n will be equal to 3. So by substituting the value over here, we get 18. So fourth shell, it is called as N shell, and by using the formula 2n square, we can find out the number of electrons where n equals to 4. So we get 32. And the fifth shell is called as O shell, and the number of electrons over here can be found out by using the formula 2n square. So if you see over here, it is 50 by substituting the values where n equals to 5. So we conclude that there are 2 electrons in K shell, 8 electrons in L shell, 18 electrons in M shell, 32 electrons in N shell, and 50 electrons in O shell. You can see over here as well. In K shell, 2 electrons. In L shell, 8 electrons. In M shell, 18 electrons. And in N shell, 32 electrons. Okay. Now, if you see over here, as the value of n increases, shell number increases, the distance of electron from the nucleus increases, and the energy of the electron also increases. Now, if you have a look over here, they are saying that each shell has a fixed energy. It depends upon the distance of electron from the nucleus. If you see this structure of atom, now this electron, it is nearer to the nucleus. So this electron is having lowest energy because there is a stronger attraction of the nucleus on the electron. So we say that due to stronger nuclear electron attraction, electron is nearer to the nucleus and it will have low energy. It cannot move easily. Now, if you see over here, this electron is a little bit away from the nucleus, mean to say that there is less nuclear electron attraction. So we say that electron is a little bit far away from the nucleus, so it will have less energy. Now, if you see over here, electron, it is very far away from the nucleus, so it is having higher energy, because if you see over here, it is away from the electron is away from the nucleus, and there is very less nuclear electron attraction. So this electron is having high energy. It can move freely around the orbit. So we say that the distance of electron from the nucleus increases, so the energy of electron also increases because electron is moving away from the nucleus. We will continue our topic in the next video. Thank you.